Okay, so this might sound a little bit strange because they're out of order, but long story, I needed to go back and amend because I forgot to hit record when I did these earlier today. So tricks or things to keep in mind when you're writing your equilibrium constant expressions. That's kind of the theme of what we're doing here. So one of the things is if you have anything, a reactant or product that what you can tell is, or I should say, if your equilibrium is occurring in water, aqueous solution, if you have water as a reactant or product, it goes away. So it kind of looks like this. It does not appear in your equilibrium constant expression. So then that means, for instance, here we have, I can tell it's occurring in water because I have AQ next to my reactant, or one of my reactants and two of my products, or my two products. So that H2O liquid will not appear in our equilibrium constant expression, so it looks like this. So we simply have the NH4 raised to the first power times the OH minus raised to the first power divided by the NH3 raised to the first power. H2O does not appear. The equilibrium constant, by the way, for this equilibrium is 1.8 times 10 to the minus fifth. And remember we said that if you have something relatively small like that, okay, that means that you have, that means that the denominator is large and the numerator is small, or the stuff in the numerator is small. So that means it favors the reactants, okay? So favors the reactants. What other sort of tricks do we have? Well, here's another trick. If you have something in your chemical equilibrium that has an S for solid or an L for liquid next to it, that also does not appear in your equilibrium constant expression. So let's look at an example of this. Now, in this case then, when we write the equilibrium constant expression, this will not appear, which is kind of weird because it's our only reactant. So actually the equilibrium constant expression for this looks like this, where it simply is Kc, your equilibrium constant, is equal to your products raised to their stoichiometric coefficients. Okay, the reactant does not appear because it's a solid state. By the way, the equilibrium constant for this is very small. So again, if you have Kc that's very small, that very much favors the reactants. And the reactants here is your solid. So by the way, we're going to be talking more about this special type of solubility equilibrium. But can you see where if it favors this very greatly, then basically what this is the undissolved. Indissolved. Dissolved here, and this is the dissolved. As it turns out, silver chloride is what we say basically insoluble in water, which means it's soluble only to just a small amount. So here is your assignment slide. We'll take a quick look at those like we did earlier. Let's see. And I went with a B here, 15. Looks like this. Okay, so I went ahead and for your hints, I basically took A, B, and C, and they gave the chemical equilibrium in words, and I went ahead just for you and I put them out in terms of what they are. But notice I have little red squiggles there. You need to balance these equilibria before you go ahead, and what you're tasked to do is write the equilibrium constant expressions for these. And my little hint there in green says, don't forget that if something has an S next to it, that will not appear in your equilibrium constant expression, nor if it has an L. So there's that one. And then the next one looks like this. Not bad. So basically you're going to take, it's always products divided by reactants. So in all raised to stoichiometric coefficients. So last but not least, don't forget that solids don't appear and neither does water. The last one looks like this, where this kind of reminds me of the standard molar enthalpy of formation. So basically they say in A, for instance, you're supposed to form 1 mole of HF, and it's going to come from the elements in their standard state. So it's going to come from H2 and F2. Okay, but don't forget to balance it then, and then write your equilibrium constant expressions.